Hi guys, Ace here again. Gonna do another space art tutorial video. This time, it's the next planet out from the sun from last time. It's the big turquoise ball of methane. You know the one I'm talking about. Okay, as before, let's create this time, though, 4,000 for the height and 3,000 for the width, because this planet is tilted on its side, like practically a right angle. It's one of those mysteries of the solar system. Let's fit on screen. It's one of those mysteries of the solar system that is hotly debated. Some people think it was a series of collisions in the early solar system that knocked it on its side, though I'm not so sure about that myself. I'm not an astrophysicist, but Uranus is not solid. It's a gas or giant, or rather what scientists call an ice giant, since whereas Jupiter and Saturn are like 95% hydrogen and helium, the Uranus and Neptune are more like 20% hydrogen and helium. The rest is mostly things like methane and water and ammonia. There's a bit of rock on the inside. And they're obviously very cold since they're, much even further from the sun. From their vantage point, the sun just looks like a brighter star in the perpetual night sky. And interestingly enough, Uranus itself, I'm getting distracted here, Uranus itself is the coldest known object in the solar system. Colder than its own moons and ring system. Wrap your head around that. So one of the reasons why it's so mysterious and why we really should send another probe there, our only real up-close data from this planet is from Voyager 2, which you may have heard fairly recently. NASA scientists, scientists in general, uncovered data from the Voyager 2 probe that it had recorded back in what was it, 82? Well, over 30 years ago anyway. Or close to, no, yeah, a long time ago. Yeah, I'm losing track of life. Anyway, yeah, I'm not focused. I need to create a new layer here. This is an art tutorial. Yeah, sure, I can talk a bit about science and stuff as I'm doing it, but this is primarily an art tutorial. So here we go. There's starting off with the turquoise-ish circle, fuzzy circle, as before. Also as before, magic wand tool, the Photoshop user's best friend, or at least mine. Feather, contract, feather, a little more, little less. That'll do it. And yeah, basically, something I always found neat about Uranus is that unlike the other gas giants and ice giants, whatever giant gassy planets, is that it has no visible features. It's just pale turquoise all around. I mean, you can discern features in other wavelengths like infrared and UV, but in visible light, it's just a big fuzzy blue ball. And I always kind of thought that was neat. I mean, most, scientists, astronomers think that it makes it look boring, but I like it. I don't know. I'm weird that way, I guess. I just like perfect geometry, I guess. Just featureless spheres. Okay, that's a little too intense. Let's reduce that opacity a bit and switch to multiply. Our good old... There we go. Let's... A few more here. Let's make this bigger. There we go. And there we go. And we're going to want to, as before, a little bit on the light side. Even though it's so far from the sun, it still does get enough light that you'd be able to see it if you were close enough. Or just through a telescope. You can actually find it with, a moderately sized, home backyard telescope if you know where to look. Something I've always actually wanted to do but never really got around to is actually find Uranus in the night sky with my telescope. I have one, but I haven't used it in a very long time. I just gonna do soft light for the light side here. A little bigger. Let's do a vivid light, but that's not it. Come on. There we go. And a pin light, but more white. There. Now we have the planet itself, but just doing that on its own would be kind of boring. I just said I like the look of Uranus because of its plainness. But I'm sure most people would want to see a bit more than just a fuzzy ball, since this is a planet and not just a Nerf ball. By the way, yeah, that's something else long time ago, back in the early 90s when I was like 5 or 6, back when Nerf actually made things other than just Nerf guns with Fortnite plastered on them. I mean, don't get me wrong, I have a few Nerf guns and I like, and they're cool and all, but they actually used to make like sports equipment toys, sort of. Like they'd have like these foam footballs, soccer balls, basketballs. Well, not really basketballs. Since they're foam, you wouldn't really be able to play with them the same way as the real thing, but they're basically designed to, toss around the yard like Tommy Wiseau. And some were just plain foam shapes. And I had one that was exactly this color, and it was just a ball, and it was foam, soft, squishy foam, and I would actually pretend it was the planet Uranus. Yeah, I had this, this sort of plastic ring thing from another, kids' toy set. I think it was like Discus or the game where you throw the rings onto the stick. I have no idea what I'm even... But... Okay, but yeah, and I would just put it... It was like the perfect size to just fit around it, and I would just I would just pretend it's Uranus. Speaking of that ring, however, that's what we're going to start with to actually make this look more like a planet. I'm gonna do this. Yeah, focus here. Come on, layer. There we go. Like we did with Saturn, but not nearly as pronounced. Because Uranus's ring system is rather faint. Like, very faint. Like, it actually took Voyager 2 to actually see them at all. You can't really see them from ground-based telescopes, even the big ones. Actually, since this is the biggest I can make the brush tool, it's not quite big enough. So, although I suppose I could just stretch it. So yeah, let's do that. Just this. Although, on second thought, this is better. Circle. Here we go. Let's do from the center here. There we go. And again from the center. It's, you know what, that's fine. It doesn't need to be perfectly centered since it's on an angle, so it's okay if it's a little off kilter like that. Like Uranus itself. As before, simplify each of these layers. Simplify, layers. Also as before. That's the wrong layer. Let's do this. Feather a little bit more. There we go. Oh, wait. Hold on. Forgot something. Undo that. Resize, reveal all. There we go. That's better. Wrong layer. Come on. There we go. There we go. What I need to do now is actually just make this a little wider, because that's gonna screw up the select if I don't. Resize. This is an easy way to do that. Just line tool, then reveal all, then just delete the line layer. There we go. And now you've made the your working space bigger. Let's do that. There we go. And there we go. Fuzzy that up. Do the same with this one. Even though we can't see it underneath the other layers, it doesn't matter. It'll do the same thing. Seriously? There we go. Select, deselect. Okay. And now what? We're going to go back to the ellipse tool again. Go full black with that, because we're going to use it to... This time I am going to just a little bit more because these rings are pencil thin. You're in the wrong place. Layer. There we go. Simplify layer again. Merge down. Let's do that. And I'm gonna not expand that as much, but there we go. Because yeah, these rings are just incredibly thin. That's why they're so hard to detect. Because they're actually they're not even gray like that. They're like they're blacker than tar. But you know, with enough sunlight shining on them on just the right angle, and you have the right lens, you can make them out as being kind of grayish. You know, like how the surface of the moon is actually like, you know, the lunar regolith, especially in the darker spots, like the Marinas, whatever they're called, are really dark, but the sunlight is so intense on them that it makes them look a little bit lighter, more grayish. But it's still way too dark to be detected easily by ground-based telescopes. Same as before. Simplify layer. Merge down. Let's do that again. Same as before. Just as a precaution, as always, save. I don't want a PNG yet. Uranus tutorial. There we go. Save the Photoshop file like that. Because this program is very old and quirky, and it might just randomly close on me. It does that sometimes. That's why I need to save a lot. Okay, there we go. And let's move this again. Just center it right there. It's good. Simplify layer. Merge down. Same as before. The select tool and fuzzy that ring up. There we go. Now they actually look like rings, but as before, we need to merge these down. And we also need to duplicate the layer like we did with Saturn. Put one of them behind. Now we need to select both these layers so that when I do this, there we go. Actually, yeah, the angle that I made this means I don't really need to have it. Didn't need to double layer it, did I? Or do I? Let's see. What looks better? No, the angle that I shaded it at makes it actually. We don't even need that that other layer. I can just do this. Here we go. Trying to picture in my head what it should look like from other angles. And I think that is good right there. Don't need that layer. However, I am going to stretch this in both directions. In fact, I'm going to do this. There we go. And there we go. Because these ring systems stretches out pretty far from the planet itself. So here we go. Just a little bit inward like that. And there we go. Imagery size, reveal all again. Now this background's got to be, there we go. Let's save this again. But yeah, as I just add the finishing touches to these rings here, whoops, it's well, what I'm actually gonna do is darken them a bit. There we go. And reduce the just a little bit because they're very faint. Now, put some stars in the background. Pin light. 99% opacity. Start with the big ones. Although, with the image this huge, even the big ones are tiny. As I was gonna say, some more science-y stuff. First of all, there's a misconception that Uranus would smell like, well, flatulence because of the methane. Methane has no odor. Methane is odorless. That misconception is because, well, you know, it's a well-known fact that most human farts and most animal farts contain methane. That's not what creates the smell. It's another gas called hydrogen sulfide that creates that rotten egg smell. And farts are actually only maybe 10 to 15% methane. The rest is mostly carbon dioxide and actually, believe it or not, hydrogen gas, H2, which is actually what makes them more flammable. You know, like those stupid-ass videos of, literally stupid-ass pun, of people lighting their farts on fire and it, you know, burns blue. Some of that is the methane, but most of that is actually the hydrogen, because hydrogen gas is way more flammable and explosive than methane, and that's what makes doing that so incredibly dangerous. So don't try it at home. So yeah, it's one place in the solar system that might smell like fart is Jupiter's moon Io, because it's like spewing out sulfur all the time, but most of that is actually sulfur dioxide, which actually smells like burnt matches. But then again, you wouldn't really be able to smell anything anyway, because the atmosphere is so incredibly thin, much thinner than Mars, you would just die. You wouldn't be able to take a breath. And similarly on Uranus, there's no oxygen in the atmosphere, at least not enough to breathe, and it's also like incredibly cold. Like I mentioned before, it's the upper atmosphere of Uranus is colder than its own moons and rings. So you just instantly freeze. Anyway, so here we have the planet there. Now, should I add a moon? Let's see, view fit on screen so we can get a better view of this. I feel like I need to crop this. There's a garbage area right there. I will add a moon. The most popular one, mostly because of its mishmash kind of surface. It's often thought to be like a bunch of smaller moons just sort of collided together to create this thing. Have it be closer in the foreground for space, I guess. Oops, that's wrong layer. I want it new layer. There we go. I'm gonna select that, and I'm going to this will be interesting. Let's see which tools will actually get that stripy kind of cracked result that we want. I'm gonna go with this brush tool first, see if that I mean, it's a start, but I want something that's more. Let's try this one. It's gonna make it's again it's a little smaller. For this part, let's again this moon is going to be difficult to actually get right with just these brush tools. I'm limited with what I have to work with here, so it's not going to be perfect, but it will look like a lumpy gray moon, which is good enough. But yeah, one other thing about Uranus that was discovered fairly recently in the Voyager 2 probe data. I was talking about this near the beginning of the video, then I got distracted, as always. It detected something in its magnetic field. First of all, for context, Uranus's magnetic field is weird. It's not straight up and down, north south like a bar magnet like Earth's is. It's like bent at a strange angle. Like, I'm just going to finish up this moon here, and then I will for the purpose of science-y stuff, I will try and show you what I'm talking about here. Soft light, good enough. I'm going to make it just a green dot that I'm going to erase later. After I'm done explaining this. Yes, I know this is supposed to be an art tutorial, but I just want to talk science for a moment here. Now let's say, Uranus spins on its axis on its side like that, so that would be the North Pole. South Pole would be somewhere there. Well, okay, let's go behind the thing. There. Its magnetic field, which I'm going to put in purple. Let's say South Pole, whoops, let's say South Pole up here. North Pole maybe around back here somewhere. Behind the planet. Yeah, you won't even be able to see it because it's behind it, but like, yeah, there. Now let's get rid of those that we don't need. Save this again. And I'm going to save it as a PNG. But before I close this up, I'm just going to finish explaining what this this science report was talking about. And yeah, so because of Uranus's wonky off-kilter magnetic field and its wonky off-kilter rotation, the magnetic field lines are barreling all over the place all the time and just sort of cycling around like in a washing machine. And this creates some weird effects in the atmosphere because all planets that have magnetic fields, including Earth, have these things that are called plasmoids, where when the magnetic field lines on the side facing away from the sun get tangled up in loops, they sometimes trap a little bit of the atmosphere and turn it into ionized plasma. When those magnetic field lines snap, much like on the surface of the sun, just, not as nearly big a scale, they release that ionized gas out into the far reaches of the solar system. Uranus's plasmoids, as the Voyager 2 probe had detected, which we didn't have the computing power back in the 80s to analyze, but we do now, is so enormous, so substantial, that it's theorized Uranus may have lost almost half of its mass since its formation to these plasmoids, that it just kept burping and, farting them out throughout its lifespan. At one point, it may have almost been as big as Saturn. And since, as I mentioned before, magnetic field lines in really weird, wonky places like that, let's do a really big one to represent the plasmoid, which wouldn't be visible to the naked eye, or even only the most sensitive instruments and computing can actually detect this thing. But let's imagine it's jetting out like that, out the back side like that. It gave me a theory as to why Uranus is off kilter. It literally rocketed itself off of its axis. Again, this is just my personal theory. I'm not an astrophysicist. I am not a scientist. I don't have a doctorate. But let's get rid of those. It's something to think about, isn't it? The whole collision theory thing doesn't really sit well with me for a gas planet. For a terrestrial planet, sure. How Earth, and the moon created, that makes sense. Because, it's mostly solid, or at least, at the time, much of it was molten iron and rock. But for something that size and that composition, that makes sense. But for something like Uranus, this theory makes more sense. It just rocketed itself over 4 billion years into being on this angle. But that's just my theory. I am not a scientist. I am an artist. That being said, save this again just because I've been Ace. Keep one up your sleeve. Until the next video, bye.